Hey guys, today we are going to learn how to solve linear systems of equations by substitution. Last class we learned how to solve them by using the graphing ability, and we also checked it using Desmos. Today we will be learning about substitution. Please keep in mind you do have to know the various methods and how to use them. You won't always be able to, you'll be able to use Desmos to check your answers, but you will have to show your work. So at first it seems a little confusing, but we're going to fill out the first part of the notes, and then it should make sense when we start doing some of the examples. So the first thing we're going to do is we're going to solve one of the equations for one of its variables. Okay. All right. And when possible, we're going to solve for the variable that has a coefficient of 1. So remember, the coefficient is the number that is in front of the variable. So we're looking for the variable that has a coefficient of 1. That makes it the easiest to use substitution. Okay, we're then going to substitute the expression from step 1 into the other equation to solve for the other variable. And we're going to then substitute, the value from step 2 into the revised equation from step 1 and solve. And then we check our answer. And you can check your answer by hand or by using Desmos graphing. Okay. All right. So what does that mean? Okay. Let's look at our first example. So here we have a linear system. And remember, sometimes we see these funky little brackets, okay, not always. But here we have two equations, okay, and we want to figure out what our intersecting point is. So we want to solve for both x and y. Okay, and how we do that, the easiest way with substitution is to notice that in the first example, see how we're already solved for y? It actually sets it up. It's really nice. Y is already 3x plus 2. Okay, so we're already solved for y in the first equation. So in the second equation, we're going to circle that y. Okay, circle that y. Now, because it's already set up for it, we're then going to substitute in this expression, 3x plus 2, into that y. So what happens is, if you notice, 3x plus 2 is going to be right here. Okay, we just took that whole expression, we substituted it in for y. And don't forget, we're keeping it in parentheses because we need to distribute it. So we then take this equation. Now right here, notice now we only have one equation. One variable rather. So we only have one variable. We can solve for x. So we do that by distributing. Okay, so we've got our 6x plus 4 is going to be equal 11. We combine our like terms, okay, and now I'm just going back. I'm solving my multi-step equation. I bring the 4 to the other side, so 7x is going to be equal to 7. And then I'm going to divide by 7, so x is going to be equal to 1. Now each step, you're not going to notice what I'm doing in each step. At this point, you should know how to solve a multi-step equation, okay. So now we solve for x. We have x. So, we're going to take the x is equal to 1, substitute 1 for x in the original equation to find the value of y. So what does that mean? We take this x, all right, and we go right back here to equation number 1. See how it says y equals 3x plus 2? Well, now we're going to say y is going to be equal to 3 instead of x. We're going to put it in a 1 plus 2. So that's going to be 3 plus 2, which is 5. So the solution would be our x is 1 and our y is 5. Okay, so right here we actually did substitute in 3x plus 2 for a y. Okay, so this 3x plus 2 right here is substituted in for the y here, and then we solve. Okay, let's do another one. All right, so looking at these two, okay, for me it makes more sense that we're looking for a coefficient of 1. In this case, we have x has a coefficient of 1. So we're going to start out by solving for x. We bring the 2y to the other side, so we get 2y minus 6. So there's our expression, 2y minus 6. We are then going to circle our x in the second equation. Okay, we're going to solve, so we solved equation 1 for x, and we're going to substitute in 2y minus 6, okay, for x in equation 2 and solve. So we're taking this 2y minus 6, we're substituting it in there, okay. So when we do that, we've got 4 times, no longer do we have x, but 2y minus 6, okay, plus the 6y is equal to 4, okay. So when we distribute, we're going to get our 8y minus 24 plus 6y is equal to 4. Combine our like terms, 14y is going to be equal to 28. Okay, when we divide by 14, our y is going to be equal to 2. All right, we now take that 2 Okay, we're going to substitute 2 now into the revised equation in number 1. So we're going back up here where it's revised. We're solving for x. So x now is going to be equal to 2, and we said our y is 2 minus 6. X is 4 minus 6, which is negative 2. So our x is negative 2, and our y is 2. Now remember, you should go back to Desmos, put both of those equations in, and check to see the intersecting point. Same with number 1. I should have mentioned that. Okay, always go back to your original 2 problems, put them in, and then check it in Desmos. Okay? All right, so we're going to do some practice problems here. All right, I'm looking at this system. I'm going to solve for y in number 1 because that's the easiest. We have a coefficient of 1. Y is going to be equal to positive 5x minus 2. Okay, because we solve for y, we're circling it. So negative 3x plus 6, we said our y is 5x minus 2, and that's going to be equal to negative 12. Okay, so now I only have one variable, so I can solve for it. Negative 3x plus 30x minus 12 is equal to negative 12, negative 20, or positive 27x. Okay, minus 12 is equal to negative 12. Okay, 27x is going to be equal to 0, so our x is actually equal to 0 when we divide by 27. Our x is 0, we plug it back in here. Our y is going to be 5 times 0 minus 2, 0 minus 2, which is negative 2. Okay, so our y is equal to negative 2. So our ordered pair is 0, negative 2. Okay, you can check that on Desmos. All right, number 2, if I look at these 2 equations, I'm going to solve for x because there's my coefficient of 1. So x is going to be negative 3y plus 1. Because I'm solving for x, I'm circling my x. Now I substitute in negative 3y plus 1. And we've got our minus 3y is equal to negative 15. 9y minus 3 minus 3y is equal to negative 15. 9y minus 3y is going to give me 6y. 6y minus 3 is going to be equal to negative 15. 6y will be equal to a negative 12, so our y is equal to negative 2. Okay, I plug my y back in here, and my x is going to be equal to, I'll do it down here, x is going to be equal to negative 3, my y is negative 2, okay, plus 1, so my x is 6 plus 1, which is 7. Okay, so my solution here would be my x is 7, my y is negative 2. Again, we can check it on Desmos and put those first 2 equations right in there. Okay, number 3, looks like I can solve for y here. Y is 5x plus 19. So because I solve for y, I circle that, and I get negative 3x minus 8 times, instead of y, we're going to put in 5x plus 19, and that's going to equal 20. Negative 3x, we got minus 40x, okay, and this is minus 152. It's going to be equal to 20. Negative 43x, okay, minus 152 is 20, so negative 43x is equal to 172. Then when we divide by negative 43, we end up with x is negative 4. Okay, we plug that back in to get our y. Our y is going to be equal to 5 times negative 4 plus 19, which is going to be negative 20 plus 19, which is negative 1. So our solution would be negative 4, negative 1. Okay? All right, so now we have a special case. All right, watch what happens here with number 4. Number 4, let me do it in another color so it doesn't get too confusing. Okay, we're going to solve for y here. So we'll do, let's do it here. Y, we'll do this one. Y is going to be equal to x plus 3. All right, and I'll circle my y right there. Okay, so when I plug it in, I've got negative 3x plus 3 times x plus 3 is equal to 4. Negative 3x, all right, plus 3x plus 9 after I distribute is 4. Now watch what happens here. The negative 3x and the positive 3x cancel out. We're left with 9 is equal to 4. So this is one of our special cases. 9 equals 4 is false. So that means our solution is no solution. Okay, so what's going to happen, actually, if you graph both of them on Desmos, you will see that they both have the same slope, so they're parallel, so there's no way it's ever going to cross. So that's how we run into the no solution situation. Okay, so I'm going to have you guys try up to number 10, okay, and then compare it against the answer key, and you can go onto the answer key and check it out, or I'll give you the answers from here, but I'm going to pause this right now, and I'm going to come back in the next video and go through number 11 on, which is the word problem. So I want to kind of split it apart into substitution first and then the word problems.